Let's look at another simple constructing a truth table problem. Here we want to construct a truth table for the statement, the negation of the compound statement P and Q. The basic idea here, as we've done before, is to produce a table that has every possible value of P and Q, and then you want a column for the truth value of the statement as a whole. So you'll end up with something like this, and you've got to list every possible value of P and Q. In other words, they could both be true. P could be true and Q could be false. P could be false and Q could be true, or they could both be false. And then you're going to use these values and evaluate the compound statement, and the final truth value for the compound statement goes there. But as you've seen me do these before, the way I do these, and again it's not the only way that can be done, is I basically take this final column and expand it and give me some room to show my preliminary steps so that I can work inside the table and yet have room to show my work. So all I've done here is I've taken this third column and I've just given myself more room to work. But I still have the same possible true, false values for P and Q. And then as usual, I take these actual T's and F's and plug them in where they belong. So if I let both P and Q be true, this statement turns into the negation of the compound statement true and true. Now I could keep working across, but I'm going to stop and just work my way down. You can go either way, but I think for teaching purposes it's probably better to go down. Then I go to the next row and I let P be true and Q be false, so I get the negation of P is true and Q is false. And moving right along, I get the negation of P down the third row is false and Q is true. Last row, both are false, so I get the negation of false and false. Now I want to go back and simplify each of these. Working inside the parentheses, I see that each of these is an AND. That brings me back to knowing the truth values for our basic tables that we've done so far. And I won't go over these very much right now, just pick out the one I need. There's the negation that we've had. You basically take the opposite of whatever the statement was, it becomes the opposite for the negation. Or you have P's and Q's, and the OR is only false when they're both false, everything else is true. And with the AND, it's only true if they're both true, so there's only one line in an AND truth table that has a true, and that's when they're both true, everything else is false. And since this is an AND that we're looking for, we're going to look at this one, and I'm going to remember the phrase only true if they're both true. So going back to the problem itself, it's only true if they're both true. Well, they're both true here, and that's the only place where they're both true. So inside of here, they're both true, so that's going to be true. But remember, there's still a negation out there, so it's the negation of true and true, which is true. In other words, don't forget those negations, and to make myself less likely to do so, I'm going all the way down and getting them in there already. So with an AND, it's only true if they're both true. So if you look here, they're only both true there, so everything else is false. However, these truth values have a negation in front of them, so I can simplify them one more time by noting that not true is false, not false is true, not false is true, and not false is true. Now, when I'm ready to show someone my answer, I really want to get rid of all my busy work here, my preliminary work. So I'll write the chart again, taking out the preliminary work that I did just to get the answer. So my final step here would be to put the possibilities back in, and then get rid of all the preliminary work on each step and just leave the final results. And I would have F, T, T, T. So to answer the question, This is the truth table for the original statement. It's not difficult. Take your time, one step at a time. Be careful.